Welcome to Signed URLs. Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Today I'm going to walk you through implementing Google Cloud Signed URLs for EduTech University's digital learning platform. As you know, we've been facing challenges with securely distributing course materials, lecture recordings, and assignment files to our students. Signed URLs are going to be our solution. Think of a signed URL as a temporary, secure pass to access a specific file, like giving someone a visitor badge that expires after a certain time. This ensures only authorized students can access materials during their enrollment period. The challenge we face. Let me paint a picture of our current situation at EduTech University. We have thousands of digital assets, video lectures that can be several gigabytes, PDF textbooks, assignment files, and research papers. Right now, we're either making everything public, which violates copyright agreements, or managing complex ACLs for each student. Neither approach scales well. With signed URLs, we can generate time-limited access links on demand. When a student logs into our portal, we can create URLs that expire in 24 hours, ensuring they can download their materials but can't share permanent links. This diagram shows our current architecture and where signed URLs fit in. Setting up a service account. Before we can create signed URLs, we need a service account with the proper permissions. Think of this as creating a special user account that our application will use to sign URLs. Let me show you the exact commands. First, we create the service account. I'm naming it EduTech URL Signer. Make sure to use a descriptive name that your team will understand. The display name is what you'll see in the console UI. Then we need to generate a key file. This is like the password for this account. Store this JSON file securely, as anyone with this file can sign URLs on your behalf. Notice how we're specifying the key type as JSON. This is the format that most Google Cloud libraries expect. Now, we need to set up our storage buckets properly. At EduTech, we organize our content into 3 main buckets: course materials, lecture videos, and student submissions. Each bucket needs specific IAM permissions. The service account needs the object viewer role to read objects and the IAM.service account token creator role to create signed URLs. Let me walk you through these commands. First, we grant object viewer permission. This allows the service account to access the objects. Then, we need the token creator role at the project level. Here's a pro tip. Always use the principle of least privilege. Don't give admin access when viewer access is sufficient. Creating your first signed URL. Here's the moment we've been waiting for: creating our first signed URL. This command might look complex, but let me break it down. We're using the gsutil sign URL command with our service account key file. The -d parameter sets a 4-hour expiration, which is perfect for a lecture viewing session. We're signing a URL for lecture 1.mp4 in our CS 101 course. When you run this, you'll get a long URL with authentication parameters. Students can use this URL directly in their browser or video player. After 4 hours, the URL becomes invalid, even if someone shares it on social media. The beauty is that we can generate different expiration times for different use cases. Advanced options for different scenarios. Let's explore the powerful options available for different scenarios at our university. Each department has unique needs. For exams, we might want URLs that expire in exactly 3 hours. For semester-long access to textbooks, we could use 6-month URLs. For one-time downloads of certificates, maybe just 30 minutes. The HTTP method option is particularly useful. We can create URLs that only allow GET requests for downloads, or PUT requests for uploads. This is perfect for assignment submission portals. Content type enforcement ensures students can only upload PDFs for assignments, not executables or other file types. The custom endpoint option helps when using CDNs or custom domains. Let me show you how we handle some common real-world scenarios at EduTech University. These are actual use cases from our implementation. For course enrollment, when a student registers for Introduction to AI, our system automatically generates signed URLs for all course materials with semester-long validity. The assignment submission process is clever. We create PUT URLs that expire right at the deadline. This eliminates excuses about being unable to submit because the system was down. For guest lectures, we generate 48-hour URLs that we email to registered attendees. Library access is handled with 24-hour checkout periods, just like physical books. This approach has reduced our support tickets by 70%. Implementing programmatically. While GSUtil is great for testing, in production you'll want to generate signed URLs programmatically. Here's how we integrated this into our Python-based learning management system. This code shows our URL generation service. Notice how we're loading the service account credentials once and reusing them. The generate signed URL function takes the bucket name, object name, and expiration time. We use datetime.timeDelta to set expiration, which is much cleaner than calculating seconds. The V4 signing process is the latest and most secure method. In our actual system, this function is called whenever a student accesses course materials through our web portal. The URLs are generated on demand and never stored. Security is paramount when dealing with educational content. Let me share the practices we've implemented at EduTech University. First, we use IP restrictions for on-campus resources. If a student is accessing materials from the library, we restrict the signed URL to campus IP ranges. We've implemented rate limiting. Each student can only generate 100 signed URLs per hour. This prevents abuse and commercial redistribution of materials. URL generation is logged and monitored. We track who generates URLs for what content. If we see suspicious patterns, we can investigate. We also use short expiration times by default and only extend them when necessary. Remember, security and convenience are always a balance. Monitoring and troubleshooting. Even the best systems need monitoring. Here's our approach to keeping tabs on signed URL usage at EduTech. We use cloud logging to track all URL generation. The first query shows us the most accessed content, which is helpful for capacity planning. The second query identifies failed access attempts. This helps us catch issues like expired service account keys or permission problems. Common issues include clock skew, so it is important to make sure your server time is synchronized, as well as incorrect permissions and expired keys. We've set up alerts for when error rates exceed 1%. We also monitor for suspicious patterns like mass URL generation or access from unusual locations. Cost analysis and optimization. Let's talk money, because even universities need to watch their cloud spending. Here's our cost breakdown for 50,000 students. Storage and egress are your main costs. We pay about 2 cents per gigabyte stored and 12 cents per gigabyte downloaded. With students downloading an average of 10 gigabytes per month, that adds up. We've optimized by implementing caching strategies, using nearline storage for older content, and encouraging streaming over downloading for videos. The signed URL operations themselves are incredibly cheap, less than $100 per month for millions of operations. The real savings come from not maintaining complex infrastructure for access control. Our total monthly cost is around $25,000. This may seem high, but it replaced a $100,000 per year video streaming platform. Integration architecture. Here's how signed URLs fit into our broader architecture at EduTech University. This is the system serving our students across 5 campuses. Students interact with our React-based portal. When they click on a resource, the front end calls our fast API backend. The backend authenticates the student, checks their enrollment, and then generates a signed URL. We cache generated URLs in Redis for 5 minutes to reduce load on the signing service. The URL is returned to the front end, which either displays it in an embedded player or provides a download link. This architecture handles thousands of concurrent users during peak times like assignment deadlines. The beauty is that the actual file serving is handled entirely by Google Cloud Storage. We just orchestrate access. Let's dive into some advanced signing scenarios we've encountered at EduTech. These examples show the flexibility of signed URLs. Batch signing is crucial during enrollment periods. Instead of making 1,000 individual calls, we batch them. Conditional signing based on grades means honor students get extended access to advanced materials. Partial content signing is fantastic for large video files, as students can seek to specific timestamps without downloading the entire file. We use byte ranges in our signed URLs. One clever trick is that we append student IDs to our signed URLs as custom headers. This helps us track usage without compromising privacy. The CDN integration reduces our egress costs by 40%. Automation and CI/CD automation is key to managing signed URLs at scale. Here's our GitHub Actions workflow that runs every semester. When professors upload new course materials, our CI/CD pipeline automatically organizes them into the correct bucket structure, generates preview URLs for the teaching staff, and prepares the signing configuration. The workflow validates file formats, scans for malware, and even checks for copyright violations using our licensing database. Only after all checks pass does the content become available for signed URL generation. We also automate cleanup, removing old content and revoking service account keys annually. This keeps our storage costs down and maintains security. Let me walk you through the actual student experience. This is what makes all our technical work worthwhile. When Sarah, a computer science major, logs into the portal, she sees her enrolled courses. Clicking on CS101 triggers our backend to generate signed URLs for all available materials. She can stream lectures directly in the browser, download PDFs for offline reading, or submit assignments through upload URLs. The experience is seamless. She never sees the complexity behind the scenes. If she tries to access materials after dropping a course, she gets a friendly error message. If she shares a URL with a friend, it won't work after expiration. This protects our content while providing a smooth experience. If you are currently using a different system, here is how we migrated EduTech's 10 terabytes of content to use signed URLs. Phase 1 involved setting up the infrastructure in parallel. We ran both systems for a month, gradually moving departments over. The education faculty were our pilot group. They are always eager to try new technology. Phase 2 focused on migrating content. We used transfer service for bulk uploads, maintaining the same folder structure. Phase 3 was the gradual rollout, 10% of students, then 25%, then 100%. The whole migration took 3 months. A key lesson is to communicate extensively with stakeholders and have a rollback plan. We kept the old system running for an extra month just in case. Performance optimization is crucial when thousands of students access materials simultaneously. Here are our optimization strategies. Cloud CDN integration was a game changer. By caching frequently accessed content at edge locations, we reduced latency by 60%. Students in our satellite campuses especially noticed the improvement. URL pre-generation for popular content happens during off-peak hours. When a new lecture is posted, we pre-generate URLs for expected concurrent users. Connection pooling in our backend services prevents overwhelming the GCP API. We also implemented exponential backoff for retries during high load periods. These optimizations allow us to handle beginning of semester traffic spikes smoothly. Compliance and legal. Educational institutions face unique compliance requirements. Here's how we handle them with signed URLs. FERPA compliance is maintained by never including student information in URLs or object names. We use anonymous IDs mapped in our secure database. Copyright compliance is enforced through expiring URLs and access logs. We can prove that only enrolled students accessed materials during their enrollment period. For accessibility, we ensure signed URLs work with screen readers and assistive technologies. We also provide alternative formats, for example audio descriptions for videos and text transcripts, through the same signed URL system. Regular audits ensure we maintain compliance as regulations evolve. Looking ahead, here are the exciting enhancements we're planning for EduTech's signed URL system. ML-powered access prediction will pre-generate URLs based on student behavior patterns. If we know most students watch lectures on Sunday evenings, we can prepare the infrastructure. Blockchain integration for credential verification is in pilot phase. Graduated students could access their transcripts through signed URLs verified on-chain. VR content delivery is our next frontier. As we add virtual labs and 3D models, signed URLs will handle these large files efficiently. We're also exploring edge computing integration to generate signed URLs closer to students, reducing latency even further. Key takeaways. Let's wrap up with the key lessons from implementing signed URLs at EduTech University. First, start simple. Get basic signed URLs working before adding complexity. Test thoroughly. Nothing damages trust like students unable to access materials during exams. Monitor everything. You can't improve what you don't measure. Document your implementation extensively. Your future team members will thank you. Most importantly, always think about the end-user experience. Technical elegance means nothing if students struggle to access their education. Signed URLs have transformed how we deliver digital education. They're secure, scalable, and cost-effective. I hope this guide helps you implement them successfully at your institution. Thank you for your attendance. Please consider subscribing to the channel.